Have you ever wondered why your state-of-the-art computer, a machine with more processing power than the entire world possessed in the middle of the 20th century, still stutters when you try to open a simple text document? You sit there, staring at a spinning wheel of frustration, wondering where all those gigahertz and gigabytes actually went. The answer is not a mystery of physics, but a crime of engineering that is about to reach a violent breaking point. By the year 2026, the global tech market is projected to hit a wall that will make your current frustrations look like a pleasant memory. We are entering the era of the great memory crisis, and the price of your digital life is about to skyrocket because of a terminal disease called systemic obesity. Before we dive into the wreckage of our current technological landscape, I invite you to subscribe to this channel and join us as we peel back the layers of the digital illusion. If this video feels a little bit slow, or if the quality seems lower than what you're used to, do not check your connection. That slight lag, that tiny bit of buffering, and the strain on your system is the very message I am trying to deliver today. It is a preview of a world where hardware can no longer outrun the sheer laziness of modern software design. In the year 2026, RAM prices are expected to surge to levels we have not seen in a decade, driven by a shortage of supply and a desperate, gluttonous demand from every corner of the industry. But the rising cost of memory is just a symptom of a much deeper, more disturbing reality. We have built a digital civilization on a foundation of waste, and the cracks are finally starting to show in the silicon. Modern computing is currently suffering from a condition I like to call systemic obesity. Just as a body becomes sluggish and fragile when it carries too much weight, our software has become so bloated that it is nearing a structural collapse. We are no longer writing code to solve problems. We are piling layers of digital fat onto our systems until they can barely breathe. Every time you update an app, it gets heavier, slower, and more demanding, even if the actual features remain exactly the same. This is not progress. It is a slow-motion car crash where the drivers are the tech giants and you are the one stuck in the passenger seat. We are reaching a point where no amount of hardware power can compensate for the catastrophic inefficiency of the programs we use every day. To understand how absurd this situation has become, we have to look back at what we used to be capable of achieving with almost nothing. In 1969, the Apollo 11 mission landed human beings on the moon using a computer with only 72 kilobytes of memory. That is less memory than the space taken up by a single low-resolution icon on your desktop today. Think about that for a moment. The most complex journey in human history was navigated with less computing power than a modern washing machine. Today, opening a simple word processing document or a group chat can require several gigabytes of RAM. This massive increase in resource consumption is not justified by any equivalent increase in complexity or utility. It is driven by pure, unadulterated waste and a total abandonment of technical discipline. In the early days of computing, engineers were forced to be artists of efficiency because they had no other choice. Every single byte was a precious resource that had to be fought for and defended with clever logic and tight code. If a program was 1 byte too large, it simply would not run, so optimization was a matter of survival. But as the miracle of Moore's law took hold and hardware began to double in power every 18 months, that discipline slowly evaporated. Optimization became an optional luxury, then an annoying chore, and eventually it was ignored entirely. The abundance of hardware power became a drug that allowed developers to stop caring about how much memory they were wasting. This shift in mindset led to what we can call the original sign of modern software, which is the creation of endless layers of abstraction. Instead of writing code that talks directly to the hardware, we now build software on top of frameworks, which sit on top of libraries, which sit on top of virtual machines. Each one of these layers adds a massive amount of weight and complexity to the system, all in the name of making it easier for developers to work. It is like building a house by stacking 1,000 different trailers on top of each other instead of just laying a solid foundation. These layers of abstraction have made development faster for companies, but they have made the end result incredibly fragile and resource-intensive. Modern software today resembles a massive, crumbling pyramid built through the application of brute force rather than careful design. Unlike the ancient systems of the past that were built for durability and precision, today's apps are held together by digital duct tape and hope. If you change one tiny line of code in a modern operating system, the whole structure might come crashing down because no one truly understands how all the layers interact anymore. We have traded deep understanding for convenience. And the price of that convenience is a system that breaks under the slightest pressure. This fragile architecture, is why your computer feels slower every single year despite the hardware inside it being objectively faster. We are currently living in the Electron era, which is perhaps the most egregious example of this systemic waste. Applications that used to be simple, lightweight tools, like your chat client or your code editor, now bundle an entire web browser engine just to display a few buttons and text boxes. Each time you open one of these apps, you are effectively launching a hidden version of Google Chrome in the background. If you have 5 of these apps open, you are running 5 different browser engines, each one eating up hundreds of megabytes of RAM. This duplication of heavy runtimes is a primary reason why your 16 gigabytes of memory feels like it is constantly on the verge of disappearing. The historical contrast is truly staggering when you realize that an entire operating system from the mid-1990s required less memory than a single browser tab today. Windows 95 could run in just 4 megabytes of RAM, providing a full graphical interface and multitasking capabilities. Today, a single web page containing nothing but a few paragraphs of text can easily consume 200 megabytes or more. The web itself has undergone a mutation, transforming from a collection of lightweight documents into a bloated mess of applications. We have lost the ability to deliver information without dragging along a mountain of unnecessary scripts and assets. If you look at a web page from 20 years ago, it was composed of simple text and maybe a few small images that weighed only a few kilobytes. Today, that same content is buried under megabytes of advertisements, tracking scripts, and heavy frameworks that provide no value to the user. The content has not changed much, but the delivery mechanism has become incredibly inflated. These trackers are constantly running in the background, spying on your clicks and movement, while silently draining your system resources. The web has become a battlefield where your hardware is the collateral damage in a war for your data. This cycle of bloat is not an accident. It is a carefully engineered business model designed to drive demand. A small group of companies dominates the global RAM market, and they benefit immensely when software becomes heavier and more demanding. As programs grow in size, users are forced to upgrade their hardware more frequently just to keep their systems functional. This creates a self-reinforcing loop where software bloat drives hardware sales, and hardware advances provide more room for software to become even more bloated. It is a parasitic relationship where the tech companies win, and the consumer is left holding the bill for an upgrade they should not have needed. The incentives for the people who actually build the software are equally skewed toward waste. In the modern tech industry, developers are rewarded for shipping new features as quickly as possible, not for making those features run efficiently. Users notice a new button or a fancy animation, but they rarely notice the extra 50 megabytes of RAM being consumed in the background. Since efficiency is invisible to the average consumer, it is the first thing to be sacrificed on the altar of the quarterly deadline. Waste goes unchecked because there is no immediate financial penalty for writing bad, heavy code. We have also seen a disturbing erosion of knowledge within the developer community, leading to a copy and paste culture. Many modern developers no longer understand the deep mechanics of the systems they are building for. Instead of writing custom solutions, they simply stack dozens of pre-made libraries on top of each other, many of which contain thousands of lines of code that will never even be used. It is like trying to fix a leaky faucet by replacing the entire plumbing system of your house because you do not know how to use a wrench. This lack of fundamental understanding means that when a system becomes slow, the only solution anyone can offer is to buy more memory. There is a profound paradox at the heart of modern technology, where tools designed to improve the developer experience end up destroying the user experience. Frameworks that make it easy for a programmer to build an app in a weekend often result in software that is 10 times heavier than it needs to be. The industry has prioritized the comfort of the creator over the performance of the product. While it is great that more people can build apps, the cost of this accessibility is a digital ecosystem that is drowning in its own excess, are trading the longevity of our devices for the convenience of the development cycle. This leads us directly into the reality of planned obsolescence, where software is used as a tool to force hardware upgrades. Your 5-year-old laptop is likely still perfectly functional from a hardware perspective, with no broken circuits or failing components. However, it feels like a relic because the software has grown so much that the hardware can no longer keep up. This is not a natural decline, it is a forced retirement. Companies stop optimizing for older machines, effectively turning your perfectly good hardware into electronic waste. It is a strategy that ensures you remain a constant customer, trapped in a cycle of buying and discarding. The real-world impact of this systemic obesity is not just limited to your frustration or your wallet. The environmental cost of producing new hardware every few years is astronomical, contributing to massive amounts of e-waste and carbon emissions. Every time we discard a functional machine because the software became too heavy, we are throwing away the energy and resources that went into building it. The social cost is equally high. As the digital divide widens between those who can afford the latest hardware and those who are left behind on the slow, bloated web. Inefficient software is a global problem with tangible, physical consequences for our planet. We are also quickly approaching the physical limits of what hardware can do to save us. For decades, Moore's Law was the safety net that caught every lazy developer, but that law is finally starting to slow down. We are hitting the limits of how small we can make transistors and how much heat we can dissipate from a processor. Hardware can no longer be expected to double in power every few years to compensate for the increasing weight of software. We are heading toward a wall where the bloat will finally exceed the capacity of the silicon, and when that happens, the entire system will begin to stall. This looming energy crisis is the hidden cost of our digital gluttony. Data centers across the world are consuming an ever-increasing percentage of the global energy supply just to process and store all this bloated data. Even a tiny inefficiency in a piece of code, when multiplied across billions of devices and servers, results in a massive environmental impact. We are burning through the Earth's resources just to power tracking scripts and poorly written chat apps. If we do not find a way to return to the discipline of efficiency, our digital lifestyle will become a major driver of environmental collapse. We are also facing a skill crisis, where a new generation of developers has grown up without ever needing to worry about memory constraints. If you have never had to fit a program into 64 kilobytes, you have no concept of how to optimize for performance. When the hardware limits finally become unavoidable, the industry may find that it lacks the people with the skills to adapt. The art of low-level programming is being lost to time, replaced by a reliance on heavy abstractions that no one truly understands. We are building a high-tech future with a workforce that is losing the ability to understand the tools they are using. The entire system is currently in a downward spiral that is heading toward a total collapse of efficiency. Rising software demands are driving up the cost of hardware, while the slowing rate of hardware improvement means we can no longer buy our way out of the problem. This is not a stable system that will eventually find an equilibrium. It is a feedback loop of waste that is accelerating. We see the signs of this decline every day in our slower devices, our increasing electricity bills, and the rising price of components like RAM. The 2026 crisis is not an outlier. It is the inevitable destination of the path we have chosen. You can see the signs of this decline in your own home, in the devices that seem to get slower even when you are not using them for anything new. A smartphone from 5 years ago struggles to load a basic social media feed that looks exactly the same as it did when the phone was new. This is the weight of the digital world pressing down on the physical world. Your hardware is not failing. It is being buried under an ever-increasing mountain of invisible junk. We have been trained to accept this as the natural order of things, but it is actually a profound failure of the tech industry. However, there is a small but growing resistance against this culture of excess. There are communities of developers and users who are pushing back by creating lightweight operating systems and minimal software. These projects prove that it is still possible to build powerful, beautiful tools that run on almost nothing. They are the digital minimalists, the engineers who still value the discipline of the byte and the efficiency of the algorithm. These movements show us that the problem is not a lack of capability, but a lack of choice and priority within the mainstream industry. We can find proof of this alternative in the world of embedded systems, where developers are still forced to work within strict constraints. In the world of medical devices, aerospace, and industrial controllers, optimization is not optional. It is a matter of life and death. These systems are highly optimized and incredibly reliable because they have to be. This proves that we have the technical knowledge to build efficient software. We simply choose not to apply it to the consumer market. The issue is purely cultural and economic, driven by a desire for speed and profit over quality and sustainability. There is also hope in the emergence of new, efficient programming languages and design philosophies. Modern languages like Rust allow developers to write high-performance code that is also safe and reliable, bridging the gap between low-level control and high-level convenience. There is a growing movement toward local-first software that does not rely on heavy cloud services for every single task. These new approaches show that we can have a modern digital experience without the crushing weight of systemic obesity. The future of software does not have to be a continuation of the bloat of the past. The philosophy of minimalism in code is built on the idea that less is almost always better. It emphasizes small code bases, a lack of unnecessary dependencies, and a commitment to long-term sustainability. By choosing to build only what is necessary, we can create software that lasts for decades rather than years. This approach requires a shift in how we value technology, moving away from the constant pursuit of the new and toward a respect for the durable. It is about taking responsibility for the resources we consume and the impact our digital tools have on the world. We must recognize that software design carries a heavy ethical dimension that we have ignored for far too long. Every wasted cycle of a processor and every wasted byte of memory contributes to environmental damage and the exclusion of those with less powerful hardware. When we build bloated software, we are effectively telling millions of people that they are not welcome in the digital world. Coding with efficiency is not just a technical challenge, it is an ethical responsibility to our fellow human beings and to the planet. We need to demand more from the companies that build our digital infrastructure. One of the greatest tragedies of modern computing is how the classic wisdom of the past has been twisted to justify laziness. The famous quote that premature optimization is the root of all evil has been used as a shield by developers to avoid ever optimizing anything at all. In reality, the original meaning was that you should not waste time optimizing things that do not matter, not that you should ignore efficiency entirely. We have used a piece of advice meant to encourage focus as a justification for systemic waste. It is time to reclaim the value of optimization as a core principle of good engineering. As we look toward the year 2026, it is important to remember that the rising price of RAM is not the true problem. It is merely a signal, a warning light on the dashboard of a system that has been running in the red for far too long. The crisis of memory is a crisis of culture, a reflection of a society that has prioritized convenience and rapid growth over stability and care. We cannot simply wait for a new piece of hardware to save us this time. We have to change the way we think about the digital world and the way we build the tools that define our lives. The way forward requires a profound cultural shift in the tech industry and among consumers. We need to start prioritizing efficiency, simplicity, and sustainability over the empty promise of more features and faster release cycles. As users, we can vote with our wallets by supporting developers who value our resources and our hardware. We can choose to use lightweight alternatives, demand better optimization, and hold tech giants accountable for the waste they create. The solution is not more technology, it is a more intentional and careful relationship with the technology we already have. We stand at a turning point where we have a choice between two very different futures. We can continue blindly down the path of systemic obesity, toward a world of staggering waste and eventual collapse. Or we can choose to rethink the way we build our digital world, returning to a focus on elegance, discipline, and efficiency. The choice is ours to make, but the window of opportunity is closing fast as the physical limits of our world begin to assert themselves. Let us choose to build a digital future that is as lean, as powerful, and as enduring as the systems that first took us to the stars. Now I want to hear from you. Have you noticed your devices getting slower, or have you found any lightweight tools that have breathed new life into your old hardware? Let us start a conversation in the comments about how we can fight back against the culture of digital bloat. If you found this discussion valuable, please hit the like button and share it with someone who is tired of their computer lagging. And if you have not already, please subscribe to the channel to help us continue exploring the hidden forces that shape our technological world. Thank you for watching, and remember, in a world of endless noise, efficiency is the ultimate form of rebellion.